Hi, this is Jeff Coronado on behalf of JCSC, and this is Bridging the Gap. Today we're going to cover ridge board components. This is the JCSC Detail W18. A couple of things in case your monitor or your screen is glitching on you. Understand from some people sometimes that happens. Give it a couple seconds and apparently it just clears up on its own. And the hint there, get all you can from the tutorial. I know that sometimes people like to jump around a little bit, just kind of pick off something that's of value to them. You shortchange your education when you do that. Strongly suggest you just listen through the whole thing, understand the whole thing. The sooner you are able to think as a structural engineer, then the sooner your career will take off, right? Instead of just kind of picking and choosing data that you need. So anyway, that's just kind of a hint. With that, we can go ahead and jump into our detail here. Let me see if I can kind of scroll up here a little bit and then blow this up slightly. So this is a ridge board. We can, well, let's see. The ridge board is this assembly here, this element here. This is a roof. It's a gabled roof. So let's start off maybe with some of the other aspects here. So here we have the roof sheathing. You can see that it's split. The detail's split here and here, but here's our roof sheathing. And so let me go ahead and clear the screen on that. It's going to be hard to keep this all on one screen. That's okay. So there's our, let's see, we've discussed roof sheathing, roof rafters. Okay, so our roof rafters are these elements here. Okay, so that's the roof rafter on the right side, the roof rafter on the left side. We call them roof rafters. Why we don't call them roof joists, that's covered in another Bridging the Gap. Send me a message at the end of this tutorial if that's something that you need help with in terms of clarifying between joists and rafters, but we won't get into that here. All right. Okay, then our ridge board. All right, so let's get back to the ridge board. What do we have? Okay, so our ridge board again. So the ridge board is this element here that's located between the two rafters. It is a continuous element, as you can see by the red X, and I'm referring in particular to that symbolism there. You see between inside of the element itself, you see a red X. That indicates it's a continuous member. If you have a question on that, you can leave a note there at the end of the description. I'm sorry, at the end of this tutorial. But this is a ridge board. Maybe a fair question might be, well, if we look at this, how do we know it's a ridge board? And the reason that's important is because we do need to distinguish between a ridge board and a ridge beam. Okay, so this is a ridge board. Notice how it is, sorry, I didn't mean to do that. Notice its width. It is a slender element. Typically, ridge boards are maybe either made out of 2x lumber. Sometimes you might even see in real old construction, you might see 1x elements, but they are narrow. These are not ridge beams. These are not a beam. They're not beams. So they will be narrower than what you might expect a beam to be. Notice also the depth here. The depth of a ridge board we will make typically on the order of maybe one size larger than the rafter. So for instance, if your rafter is made out of 2x6, if it's 6-inch deep lumber, you'll make the ridge board be 8 inches deep. If your rafter is a 10-inch deep element, what did I say, 10-inch? Then you'll make your ridge board be 12 inches deep. You want that ridge board typically to be slightly longer than the rafter, and it's mostly because of geometry, because this rafter, once it's inclined, right, once this element is inclined, then this surface, this dimension there is longer than the rafter depth, right? So if the rafter is 10 inches deep, then this this dimension here, this dimension, that dimension is longer than the 10 inches that the rafter is. So we need a ridge board to be deeper than the rafter itself. Okay, so that kind of establishes how you size your ridge board. You want it to be probably typically 2 inches wide, a 2x, I should say, a nominal 2x, nominal 2 inches. So it's a it's a 2x. It'll be one size deeper than the rafter that you're specifying, and that will give you the size of the roof. Of the ridge board. Important to note, the ridge board doesn't carry carry any load. That's why really it's not important. There's no calculations involved. There's no stresses involved in the ridge board, okay, as opposed to a ridge beam, which would carry the weight of the rafters, the tributary weight of the rafters. If you have a ridge beam, yes, that will be a different size, but that's a whole nother matter. That's not what a ridge board is. So here we have a ridge board. Okay, let's see, what else do we have here? The collar ties. Yes, we do have collar ties here. So let's go back up the screen. Let's take a look at the collar ties. So the collar tie is basically what we are illustrating with this element here and this element here. So in case this isn't completely transparent to you, what we have here is an assembly where, let's just say, we have, say we have a wall here. Therefore, we would have a wall here. And then, let's say that we have a rafter here, and a rafter here, and we have our so there's our ridge board, okay? Again, it's a ridge board, not a ridge beam, ridge board. What we are trying to get at here is that then a collar tie is the element that we would either put or see, depending on what it is, right? If we are building this, then this is how we would see it. If we are evaluating an old roof, this is how it would look like out in real life. But notice where this rafter tie is. It is very high up on the rafters. I'm sorry, I may not have said that correctly. The collar tie, not the rafter tie, the collar tie is very high up on the rafters. So I'm showing you that with this light green. Let me use brown and draw, I don't think I want it there. Oops, I lost one of my rafters. So in brown, I'm showing you the rafter tie. That occurs, the rafter ties occur at the base or very close to the base of the rafters. That's a rafter tie. This that we're illustrating here is very high up. The ones that are shown in the red arrows, those are high up. That's the ones in the red arrow. So let me do this so that you can see the rafter tie, which are pointed to in red. I'm sorry, the collar ties, which are pointed to in red, is the element that's drawn in green in the sketch above. That's your collar tie. The collar tie is pretty old school. And by old school, I mean old, right? When I had somebody who was old school, an old timer, tell me about collar ties when I was a young timer. So imagine how old that was, right? This is real old school. When you see collar ties, we put them in. We still tend to put them in. Just I don't know, just almost for the heck of it. We really don't calculate the collar tie. There's no forces to it. And it's supposed to be what the old timer told me was that collar ties used to be put in as part of an understanding that they would resist wind uplift. Whether they really resist wind uplift or not, I wouldn't bank on it. But what the heck, you're kind of putting in a 2x4. Typically, we would specify the 2x4 spaced every so often, and again, it's very arbitrary. You're not going to put him in, probably not going to put him in at every rafter. You're not going to connect every rafter with a collar tie, but every few rafters, you'll probably throw in a collar tie. You'll put in a couple nails at each end. Again, there's no forces, no calculations. It's just old school construction. Just makes it look right, I think. Makes it feel better, makes you feel better. But again, any forces that we actually need to transfer through there, we wouldn't rely on the collar tie. We would actually put other hardware to resist the wind uplift. But again, that's what the old timer told me once a long time ago, was that collar ties were there to resist wind uplift. But again, there's no calculations, no forces that we put in on these collar ties. And the important thing to distinguish here is that the collar tie occurs very high up on the rafter. I would say within the top 1/2 to maybe 1/3 of the rafter length. That's where you'll see the collar tie, whereas the rafter tie, which does serve an important structural purpose, and that's covered in another Bridging the Gap session. But the rafter ties occur very close to the bottom of the rafter, and that's what I'm showing you here with the black arrow. Okay, so that's the collar tie. Let me clear this out. And actually, let me see here. Right, the rafter ties are covered in another Bridging the Gap. Again, rafter ties do carry forces. There are calculations involved there. And we already covered the location difference between rafter ties and collar ties. And that's the extent of it. So that's basically the anatomy of the ridge board, of a ridge board detail. Again, you can see that the ridge board detail doesn't really require any calculations. It's pretty standard, rules of thumb, if you will, is how those elements are sized. There's no real forces there in the ridge board, nothing really to calculate. So that's basically a ridge board detail, and that's the ridge board assembly. That's a typical ridge board assembly. If this was helpful to you, I sure would appreciate you giving us a thumbs up at the end of this tutorial. Any comments that you might have, or suggestions or questions, by all means, feel free to leave them and we will try to respond to it. And if you enjoyed the tutorial, appreciate you subscribing to the JCSE channel. where we post tutorials like this so that you can be notified automatically of when as new tutorials are uploaded to our channel. Okay, real good, guys.